Welcome to the office. We want to take a look at one more thing here in Cosets and Lagrange's theorem, and that's actually the idea of the index. So earlier we were talking about, let's see here, Lagrange's theorem says that the order of a subgroup divides the order of a group. So we can write the order of a group as a multiple of the order of the subgroup. And this is exactly what we want to focus on here. We have a name for n, the order of the group. We have a name for m, the order of the subgroup. And we just want to give a name to r, and we give it the name index. So the index of a subgroup is the number of left cosets in the for the group, for the subgroup. So if we have the order of a group is a multiple of the order of the subgroup. This is the index, the number of cosets of H in G. Pretty straightforward. If we wanted to, we could take a look at some examples here. We looked at examples previously, left cosets specifically here. So from this example in D4, where H was this, we have that the index is the number of cosets, 1, 2, 3, 4. The index here is 4. And this does come with a particular notation. The notation would be D4 and H. This is the notation for the index. Let me double check on that notation, make sure I have the order correct, because that is important. Group, subgroup. Excellent. Group, subgroup. Similarly, we also took a look at the left cosets of this subgroup of the 8th roots of unity, and we also saw 1, 2, 3, 4. So the index in this example, where we were considering the 8th roots of unity, and the subgroup specified there, we found this to be 4 as well. All right, so those were some really quick examples. We also want to consider a theorem here that expands this a little bit, and it actually is very closely related to our second collection of examples. So suppose that H and K are both subgroups of G, such that K is actually a subgroup of H, and H is a subgroup of G. Let's see here. Suppose that the index is finite for both of those. H in K, or sorry, the index of K in H and the index of H in G. Then we can calculate the index of K in G, right? Because K itself is a subgroup of G. And we can compute it to be exactly this thing. The index of K in G is the product of the index in H, of H in G, and the index of K in H. So that's a little bit hard to kind of read at first, but it's pretty straightforward. Since H is a subgroup of G, we can actually talk about the index of H in G. Let's see here. Let me write this a little bit differently. We can write, since H is a subgroup of G, we end up with that the order of G may be written as R1 times the order of H. R1 is the index of H in G. So it should be there we go, index of H in G. And since K is a subgroup of H, we end up with the order of H may be written as a multiple of the order of K. And R2 is the index of K in H. There we go. And then now we can do some substitutions here, right? I have G may be expressed as R1 times the order of H. Oh, well, I can write that as R2 times the order of K. Fantastic. At this point, I just need to perform a regrouping. So I have R1 times R2 times the order of K. And based on how we defined index, right, R1, R2 is the index of K in G, that is this particular notation. So GK is equal to R1, R2, but R1 is GH, index of H and G. R2 is the index of K in H. And that's exactly what our theorem states here. Excellent. So that's pretty easy to observe, right? Got to write it out, then it becomes easy to observe. It's not too bad though. If we want to see a specific example, what we can do is we can return back to our initial collection of examples here, where we were talking about, let's see, all the way back to here, the left cosets of this subgroup in that group, the group of units. Nope, I'm sorry, that was too far back. I do want the left cosets here. Excellent. So the left cosets of rho naught mu2 in D4. We actually have the scenario where H is a subgroup of D4, but this is actually a subgroup of S4. S4 is the permutation group on 4 elements, which has order 24. And we know that, for example, we also know that the index of H in D4 is 4. So what I can do is I can recognize that S4, which is 24, I can write that as, looking back at that work that we did earlier, I can write it as the index of, in S4, the index of D4 times the index of, in D4 of H times the number of elements in H, right? Based on what we wrote down earlier. So 24 is equal to this thing I don't know, S4, D4, and this index was 4, and the number of elements in H is 2. So it actually works out, if I care to know, 24 divided by 8 here is 3. That is the index of D4 in S4. Hey, cool. Okay, so I get this relationship. I get this this nice thing going on there between the index of a group, its subgroup, and a subgroup of the subgroup. Fantastic. That's all that I wanted to share for this video. So thank you for your time and your attention. That's actually the end of this section as well. So have yourselves a wonderful day.